Hello, and welcome to this part of the FAST tutorial series. In today's video, we'll be looking at how to apply the statistical model that we generated in the previous tutorial to our dataset, allowing optimized tracking. So this is the tracking module as we left off in the previous video. You can see that we've already performed our model training, and I've actually removed some of these features from the training stage. That's just so that I can illustrate something later on. But now we're going to be talking about these tools down here and these three panels. So these tools allow us to optimize the parameters for the main tracking stage. So to begin with, I'd like to talk about the test tracking box down here. This contains a slider which allows us to choose different frames within our dataset. So what this allows us to do is to apply the parameters that we generate up here and see how they work on a small subsample of our dataset. So for example, if I choose this frame here and I then click test track, you'll see that after a relatively short delay, we have this overlay appearing down here. And if I now just zoom in on this, you can see that we have these segmentations of cells overlaid on top of our original image, and that each cell is associated with a different color. Now if I toggle AB, that's just going to switch between this frame and the next frame. So frame A and then frame B. And you can see that each of these colors correspond to different cells and indicate identity assignment between frames. So for example, you can see that this cell here in the kind of light green or light cyan has been assigned to this object in the subsequent frame, which is correct. And you can see that all of the cells that we're looking at here, the assignment has been correct. These cells that are marked in yellow and magenta are cells which have not been assigned to. So if they appear in frame A, they appear as yellow cells, and if they appear in frame B, they appear as magenta cells. So this is obviously not correct. You can see that we actually want to link these two cells together. So this yellow cell and this magenta cell, we actually want to be one of these shades of green. So what that is telling us is that we need to decrease the stringency of the tracking algorithm. So to do that, I'm just going to change this adaptive tracking threshold here at the top. I'm going to increase that to 0.05, and I will reapply the test tracking. And now that's completed, you can see that many more cells have taken on one of these non-yellow colors. So if I now click toggle AB, you can see that we've got many more of these links correct, but we have a problem down here. So you can see that there is this mother cell in frame A, which is then thought to split into two separate cells in frame B, but the tracking algorithm is assigning between the mother and the daughter. Now, if we do want to detect those events, we can do that with the division detection module, but we don't want to do that in this tracking module. So we kind of need to increase the stringency again to prevent this link from being assigned. So to do that, we can bring this number down again, this detection threshold, and I can again click test track. And now that that's finished, you can see that we actually have a bit of a conflict going on here. So not only do we still have this issue down here where our threshold seems to be too lax, we also have this case up here where two cells which were being accurately tracked previously with the more lax threshold have now been not linked together. So this is incorrect. This is in fact too stringent. So these two cells, the threshold is too stringent, but here it's too lax. So there's kind of no way with feature settings as currently applied that we can actually create or make a threshold which allows a correct assignment of these objects. So to deal with this, I'm going to introduce the length feature into the mix, and I'll recalculate the model. And you can see that the amount of information available has increased, as we would expect. And now if I click test track, you can see that these cells down here, the assignment is now being performed correctly. So you see that this mother is now no longer being assigned to one of the daughters, but that these two cells up here are being correctly assigned to. And what's happened is that by introducing this length feature into the mix, we've basically said that the large length change that would be necessary for a link to be made between the mother and the daughter, we can now throw that out, whereas these two cells, there is a much smaller degree of length change between the two frames, so we can mix those back in. We can also look in this window at what's called the normalized feature space. If you want some more details on what this actually represents, you can read our preprint. But basically, for the purposes of tracking, what you want to be checking here is that the distribution of points within this circle is approximately isotropic, so symmetrical in all directions. And we can choose different features to compare against each other. So here I've just got the x and y coordinates of the cell. I can also check the length against one of the coordinates. And this dotted line represents the threshold that we're applying. So as I move that up and down, you can see that that's changing the position of that outer dotted line. Now, as we kind of move around, we can check that this particular set of parameter values is still working, and we can move to other points within the data set and make sure that everything is correct. And we can just keep kind of iterating back, trying to find a threshold that works for the entire data set. I'm gonna say that this is not too bad right now. I'm actually going to introduce another couple of features, so I'll have to retrain the model. And then I'm going to use a threshold which I know works for this particular combination of features and this data set. And so that allows us to set our threshold. I will now discuss these two parameters here. So this maximum gap closure allows us to deal with situations where perhaps we have a missegmentation or an object not detected in a specific frame. So let's choose this frame 31 again. So if, for example, one of these cells down here, the segmentation didn't work for a particular frame, let's say this light cyan cell was present in frame A, but then disappeared in frame B, but then reappeared in the subsequent frame, this gap closure parameter would, if it was increased above 1, allow us to join the gap between frames 1 and 3. So that just allows us to take care of any kind of gaps in trajectories that are introduced by missegmentations. I'll discuss this parameter in a second. Let's just run the tracking on the entire dataset now though. So you'll see that we have this loading bar up here. This is just applying the exact same process to the entire dataset rather than just to a single frame. So now that tracking is finished, we've got this track length distribution. This just indicates the total amount of data in our dataset that is associated with a particular track length. So here, for example, you can see that about 3% of our data is associated with tracks of length 10. And this allows us to choose which tracks we want to include in downstream analyses. So to exclude short tracks, we can adjust this minimum track length parameter that I glossed over previously. So for example, if I wanted to have only tracks of at least length 20 included, I would simply increase this minimum track length parameter up to 20. And now you can see that this red line has moved over to 20. So anything to the left of the red line is excluded and everything to the right is included. Now that's tracking complete. It automatically reprocesses our data sets once we change that parameter, so I can now safely close down the tracking module. And just to give you a quick sneak peek and kind of tie up this story, because I'm going to move on from this data set in the next video, I'm going to quickly show you the plotting module. So remember that our hypothesis was that we have faster moving cells that are brighter. So to test that within this framework, we can quite easily do it without any further kind of coding or any further kind of data analysis of the tracks. We can just go straight to the plotting module, choose this joint distribution option up here. We can now choose the two parameters that we want to compare with each other. So in this case, it's going to be Vmag, which is the cell velocity. Actually, I'll put that on the y-axis. So on this axis, I'm going to choose channel 2 mean, which is our the fluorescence intensity of our cells. And here I'm going to choose Vmag, so the velocity of cells. And so you can see that now that if I add this correlation coefficient measurement into the top and this linear fit, you can see that we actually have quite a nice strong positive correlation between these two variables. Now there's various other things that we need to check, of course, so whether or not there's any kind of time dependence in these variables. So we can choose the time course plot type up here and find that that does indeed seem to be the case. So maybe things aren't quite as easy as they initially appeared. But you can see that there's a kind of very simple framework with which we can start to investigate these hypotheses. So in the next video, I'm going to be discussing, just going back to the tracking module, I will discuss this button down here, which I didn't actually mention last time. This validate button allows us to manually correct and visually verify that our tracks are good. So that's going to allow us to create manually created data sets that are extremely high accuracy if they're very small. So thank you for joining me in this tutorial. I hope to see you in the next video where we'll discuss this validation module.